Okay, so this is a video to show you how to enter error compensation into an M2 readout for calibrations. Usually we extend this out to 6 decimal places and work in millionths of an inch. So I'm going to do that first. I'll go up here to the settings and I'll go into display formats, and then under inch resolution here I'm going to change this to 5 zeros and a 1. So by clicking down here I could do 0.1, 2, 3, 4, 5 and a 1, and then done, and done again. Now you can see I'm out to millionths of an inch. So for our calibration, there's 2 ways to enter the error correction. First is take a measurement and have a length measurement displayed in this results window over here on the right, and then change the nominal value of it and import that into your error corrections. That's the way they tell you in the manual. There's another way also where you can create this distance yourself using distance and putting in values for the distance, and then you can import that as if you measured something. So let's do them both. We'll take the first one. We have a distance measurement here that we just took off of a part. I have a simulator here is what I'm working with, so I just measured the distance from here to the other side of the part as a distance measurement, and I have a result over here. If you wanted to draw lines and calculate the distance between the lines to make it more accurate, you could do that. You just have to delete everything else when you're done and just leave the distance measurement over here. That's the only thing that can be in this display. Alright, so once you have the distance, you go back to the settings. Actually, before you go to the settings, you have to click the distance, and your distance will show up here. This is your actual length is here, and this is a Y distance, so your Y measurement is in there as well. Click actual and it'll change to nominal. Now you want to change this nominal to what it's supposed to be. This is what was measured, but actually we'll say our master is supposed to be 186 exactly, and we measured 887 millionths of an inch too large. So we're going to change the nominal size to our master size. So we'll just click on it, and we'll use these numbers down here again to change it to 186.186, and I'll change the Y also to 0.186. Click here just to make sure it changed correctly. Okay, now both the length and the Y are changed to my nominal value. I say done, done. Now I can import this into my error corrections. So I go up in here to my settings again, and I go to error corrections. Click that. Now over here the Y-axis says yes, which means it's on. I'm going to turn that to no. Before I can change it, that has to be no. Then I go over to the SLEC, click that. You can see my standard is 1 inch, observed is 9999 for X. I'm going to change this to Y. Y says 187 in both places. I'm going to import this new value. So now I just click import, and it says the calibration features were imported successfully. Now if I look over here, I have my standard as 186, which is what the master was, and then the observed is 186, but it has the 886 millionths of an inch too large in there. So now the error correction is what the difference is between the two. So that's the way the book tells you to enter it in, and that works fine if you want to take a measurement and enter it. If you want to enter a value on your own, you can do that as well. Let me delete this one, highlight it, click delete. So now I'll enter a value. What I'll do is I'll say distance, and then instead of measuring a distance, I'm going to go to this numerical input here, and I have x1, x2, y1, y2. So these are coordinates where I can put in a length. So I want suppose I measured a 6-inch part, and I'm 6-inch master. by 1-inch segments. I got to the end of the master, then I realized I wanted to add in 4 10,000ths of error correction. So my master would be 6 inches, and what I observed was 4/10ths too large, so it would be 6 inches, 0.0004. 4 10,000ths too big. So what I'll do is I'll make this length measurement the size that I measured, not the size of the master, but the size that I measured. So I'll put in y1, and my starting point is 0. I'll take y2 and I'll make that 6 inches, 0.0004 10,000ths. And then my x1 and x2 will be zeros as well, because otherwise I'll draw the line on an angle. So what I'm going to do now is actually draw a line or distance. Done. So now I have a distance measurement of 6 inches and 4 10,000ths. If I go to the nominal, I change this to 6 inches exactly, 6.0. I change my Y length to 6.0. Click here just to make sure it changed right. So now my nominal is 6, my actual was 4 10,000ths larger. I'm going to say done. Done to get back to my main screen. Now from here I can import this new distance measurement that I created. I'll just go back up to my error corrections again. Make sure that this is set to no, because it won't import if it says yes. It has to be no. And then SLEC, y-axis. Now it says 186, and I'm going to import the new value. We're successful. Now its standard is 6 inches. Observed is 4 10,000ths large. This is my error correction is 4 10,000ths. And that's all there is to it. And when you're done, you should go back in before you leave the machine after calibration and make sure you reset your display resolution back to whatever the customer uses. Most likely 4 places for inch, and just end in a 1. Say done, done, you're back to 4 places. And that should take care of it. Thank you.